Hello, and welcome to this reading of a student capstone philosophy paper. First, I would like to thank Dr. James and my fellow students in this class who have been wonderful editors and supporters. Now, I will simply read something I wrote about our concepts of time and the words we use to describe time. Dear Aristotle, we need two words for time. What time is it and what is time are two very different questions. Modern science has proven Albert Einstein was correct when he told us that time is a physical thing that can be affected by gravity or speed. The concept of time has been debated for ages, and most of the great philosophers have touched upon this subject. Their arguments about time have not been conclusive, but they have clarified some points about what time can and cannot be. It is understandable that in the distant past, before the breakthrough physics of the early 20th century, time was thought of in terms of the perception of time or the measurement of time. One consistent problem still continues to arise, that of treating the measurement of time as if it is the same thing as time itself. We need better definitions. To be meaningful, any statement must be true by tested facts or by virtue of logical form. Scientific rigor demands that we base our conclusions on either direct experience or logic. Prior to last century, we had no ability to employ testing methods to explore the concept of time, so logic was all we had. Our two questions here are, how do we apply scientific rigor to a subject as hard to define as time, and how can we avoid confusing measurements of time with definitions of time as an entity? The first step in understanding a thing is to describe it. A century ago, the English philosopher John Ellis McTaggart developed a scheme to categorize time. This became known as his A series of time and his B series of time. Framing time as the past, the present, and the future was his A series, while the floating reference known as the B series locates time in a relationship of earlier than and later than. This B series can be anywhere in the past, present, or future. To say, for example, that the ice cream cone was invented in 1904 at the World's Fair after the discovery of electricity but before the introduction of the iPhone is a B series reference point. The fact that McTaggart's A and B series describe two schemes to identify points in time is the taking of measurements of time, and it highlights the fact that we need an additional word with which to describe time itself. Traditionally, examinations of time have encountered this conceptual problem of semantics. Too often, the concept of time as an entity has been confused with the measuring of time. Without referring directly to that section of Aristotle in Physics 1, McTaggart's opinion coincided with another philosopher, Nathaniel Stein. They said time does not exist. Although McTaggart tells us his B series events always exist, he later defeats both series logically to claim that time does not exist. McTaggart essentially tells us that his A series and B series concepts are positions in time. He was measuring time and telling us about a contradiction involving those measurements. We are compelled to ask if the inability to clearly measure something automatically proves the thing does not exist. A gentleman named Peter T. Geach wrote a book about McTaggart, and another gentleman named John N. Findley discussed that book. Findley tells us that Geach interpreted the structures of time to be like a fabric of time. Geach could not tolerate the idea of a changeable fabric like that. Findley did not agree with Geach. In Baroque language, he disagreed when Geach said we should not allow ourselves to be bamboozled into thinking that there's a vast number of distinct things corresponding to arbitrary groupings. Findley believes in an infinite number of such things. He believes time is real. McTaggart felt there were two overall ways to look at time. His A series referenced time as describing a single moment. The now is the single indivisible moment of the present. It is a fixed frame measurement. The B series fixes the relationship between two moments, the before and the after. It is a floating measurement biangulating between two reference points. It is a measurement system. This very instance of reading this text is a setting of the A series. Talking about something yesterday or tomorrow would refer to B series settings. Of course, the same would apply to a tomorrow. To support his claim that time does not exist, McTaggart attacked his own system by discussing change.
The assumption here, which is also widely observed in philosophy, is that time cannot exist without change. This may be an instance in which McTaggart's premise assumes the truth of the conclusion. The logical structure of an argument is unsound if, as here with McTaggart, a conclusion is based on an unsound premise. He created a syllogism. A syllogism is a logic tool in the form of deductive reasoning constructed with a major premise, a minor premise, and a conclusion. The classic example of a syllogism is all humans are mortal, a major premise, followed by Socrates is human, a minor premise. Therefore, the logical conclusion is Socrates is mortal. McTaggart began with the premises that 1. Time cannot exist without change. 2. The A series cannot allow for change because inside of itself the present is indivisible. And 3. The existence of B series depends on the A series, meaning that without the fixed present moments of the A series, the B series can never be created. The moments of the B series are created by A series processes. The conclusion to be drawn from this, according to McTaggart, is that due to the conflicts of these premises, if change creates the present moment and that change cannot take place inside of an indivisible moment, then the A series cannot exist. The A series would therefore never be available to create the B series moments of time. He concluded that time cannot exist. A demurrer could be raised. One might ask if he has conclusively demonstrated that time cannot exist without change. Time is a thing we cannot see or touch. How can we know what it is? Aristotle seems to have combined concepts when he often referred to time as the number of change, then described it elsewhere as a series of nows. Aristotle's number of change most probably referred to that perspective of time as a measurement of itself. Elsewhere, Aristotle approached this question differently. For instance, when he discussed the now as meaning the present as something which is indivisible. The now is not the past, not the future, and it cannot be separated into smaller units. Wolfgang von Leyden circled around this argument in 1964 when he said, "A careful examination shows that there is a distinction between time, even infinite time, and that which contains within it time. The idea of measurement as a definition of time is problematic. It forces us, before we even try to choose between several different definitions of what time may look like, to first be certain we are even discussing time as the same thing. To measure time is not to define the nature of time any more than clocking the speed of a passing automobile explains the construction of an internal combustion vehicle." Aristotle is a good starting point for any study of philosophy of time. In the 20th century, Martin Heidegger expressed views about the way Aristotle looked at time. Heidegger pronounced Aristotle to be the founder of a line of logic that equated time to a series of nows. That description is more in line with thinking of time as an entity rather than as a measurement. In Aristotle's physics, Charlotte Weigelt tells us time deals more with our access to time rather than with time as an independent entity. What does that mean? Can we see these nows and can we understand their dimensions? Heidegger first brushes against McTaggart's A and B series of time when he tells us that time is a differentiated unity of the past, present, and future that structures human experience. Aristotle is a good starting point for any study of the philosophy of time. The 20th century philosopher Martin Heidegger expressed views about the way Aristotle looked at time. Heidegger pronounced Aristotle to be the founder of a line of logic that equated time to a series of nows. That description is more in line with thinking of time as an entity rather than as a measurement. In Aristotle's physics, Charlotte Weigelt tells us that time deals more with our access to time rather than with time as an independent entity. What does that mean, and can we see and understand these nows? Heidegger first brushes against McTaggart's A and B series of times when he tells us that time is a differentiated unity of the past, present, and future that structures human experience. When Martin Heidegger spoke of time, he was, in simpler terms, evaluating the size of time. He was measuring. He was telling us about time as the making of innumerable moments of the present, which were in the future, then turned into the past. He tells us nothing about what those moments actually are. We understand that Heidegger was seeing different definitions of time when he later talked about the vulgar understanding of time, a counting that assumes the form of a sequence of nouns. While Heidegger identified Aristotle as the founder of this understanding of time, he also referred to time as the measuring of time. He described a dimension of our perception of motion. Heidegger was looking at time as if it was a thing passing before him, and he measured the passage in units. It is counting, with little said about what is actually being counted. We cannot see time, we have no ability to experience time directly, and we rely on observing changes around us to make assumptions about what time may be. In the past, all assumptions about time have been based solely on arguments of logic without verification through testing. Time is one of those things which is not easy to observe, even with indirect methods. The results of the logic arguments we rely upon can be broadly separated into three categories. 1, time simply does not exist. 2, the past, the present, and the future all exist. Or 3, perhaps the present is all there is. In Physics 4.10, Aristotle spoke about time. His words may seem a little cryptic to us today. Time has been and is not, is going to be, but is not yet. Did Aristotle mean there was no such thing as time, or was he saying that there are different parts of time? Students of philosophy often refer back to these puzzles Aristotle left us, and three of them are applied to three very different schools of thought about what is the nature of time. Some researchers thought Aristotle meant time as an invented concept and does not exist. Others thought he was saying that the present, the now, is special because it is the place where we experience and interact with time, but where the past and the future do not exist. Yet others felt that Aristotle meant all three tenses of time are with us, past, present, future. Philosophical literature supports all three views. Nathaniel Stein commented in 2016 on the writings of Aristotle and concluded that Aristotle's words meant time does not endure. In his article, Aristotle and Parts of Time and Being in Time, Stein stated that Aristotle's argument is circular, unsupported, and the conclusion does not follow from the premises. He said that the future and the past do not exist, therefore the present does not exist. Without a better explanation of an unshakable connection between the present with both the past and the future, it is unclear why the now cannot exist based entirely upon an assumption that the past and the future may not exist. A retort to Stein might be that it is not entirely clear that Aristotle was telling us time in any of its projected parts does not exist. Aristotle described a past and a future between which exists the now. Did Aristotle describe an objective thing as time or may not exist in three parts, or was he only measuring the present separately from the past and the future, like tick marks on a ruler? Did you hear the tree fall in the forest? That is part of an old adage about existence, and it is an example of the need to define terminology. It asks us if a tree falling in the forest makes a sound if no one hears it. We could inquire here whether the measuring, the hearing of the tree falling, defines the existence of the tree. We need to define our terms and explain exactly what hearing means in this specific instance. Inductive reasoning tells us that the tree exists, and when it fell, it made sound waves. If no one heard it fall, we may infer it made sound waves which, if not heard by human ears, were very probably heard by some woodland creature, thus fulfilling the requirement for sound to be heard. Again, we're looking at two things, the tree and the measuring. It is the same with time. We see time described as the measurement of time. The sound of a falling tree is a measure of the action of the tree falling. The existence is separate from the measuring. Change is measurement. How can we say with a clear conscience that time cannot exist without change? Half a century ago, the British historian of philosophy, Richard Syrabji, may have presented us with a questionable syllogism. Syrabji believes time only occurs with change, a major premise. He says we notice time when and only when we notice change,
a minor premise. Therefore, his conclusion is that time does not exist without change. This is clearly a conclusion that does not correctly follow from the premise. Take note of the basis for this syllogism. It in no way explains to us how change creates time. When we do not notice time, is it not very possible that time simply exists without being noticed by us? Aristotle did confront the question of whether time exists, but he also fell back into the very subjective position shared by many that time does not exist unless it is observed by a person. Does the tree make a sound? Here again, we are examining an extension of the time as measurement logic in the form of puzzling about whether time does not exist if it is not measured. We turn back to the questionable argument of Syllogism, which leaps across sections of logic by telling us that we notice time when and only when we notice change. And therefore, if time is changed, then change cannot exist without the observation and notice of change. It seems immodest to assume nothing exists if we are not taking notice of it. Albert Einstein once asked his friend if he believed the moon does not exist when he is not looking at it. It seems a little arrogant of us to assume that the universe is constructed such that it will flick into and out of existence only so it can serve the needs of our sensory organs. In 2005, the philosopher Ursula Koop explored a rational explanation about why Aristotle's comments on time are cryptic to us. Koop's exact words were, "With is in the sense of now, there is no analogous tendency to think that if something is, it or a part of it must be here. A thing's relation to now is not built into the verbs used in speaking of it in the way that a thing's relationship to now is. But why should we find it any more puzzling that time can be, though no part of it is now, than that Australia can be, though no part of it is here?" She supports the eternalist argument by suggesting that perhaps the ancient Greek words from Aristotle saying, "Time has been and is not, is going to be but is not yet," might more accurately be interpreted to mean that parts of time are perhaps not currently in the present, not here now, but does not make any comment on the structure of the before and the after. The real nature of a thing, its essence, is known as its quiddity. Koop's reasoning does not distinguish between whether the idea that time's quiddity, its existence as a physical entity, is or is not defined by counting it. We do have accurate descriptions when philosophers combine the aspects of time into a single package, often being described as both time and the container within which time is contained. The measurements and the characterizations of time can both be discussed in that manner. Some researchers explored time without committing to the label of eternalist or presentist. Sarah Waterlow tells us in 1984 that Aristotle primarily saw time as a series of connected nows, which she called the fundamental point where time unites into a changeless order. Identifying a point between the past and the future is a way of combining the measuring of time with the description of it. She cites McTaggart as a clear example of this disturbing mystery of a point where endless possible futures become fixed into a solidified and immutable past. Aristotle, she goes on to tell us, happily does not get sidetracked by a feeling that he is locked into a fixed position. Aristotle told us the present, the now, is indivisible. He seemed to feel the now, although special, cannot be separated from those other parts of time. Like a politician, he adopts both positions, eternalism and presentism. In addition to the three possibilities of time, referring to the schools of thought that either time does not exist or falls into the various derivations of presentism or eternalism, many sub-schools have compelling arguments. Presentists believe only the current moment exists, while eternalists feel that some combination of the future and or the past endures. In his book, Aristotle and Time, A Study of the Physics, philosopher Tony Rourke opposes Stein and builds on Koop, but he unfortunately falls prey to the sidetrack of likening time to motion. He does, however contradictory though it may seem, believe in the indivisibility of instances. He primarily relates time to a kinetic sense of before and after. Modern physicists define motion as displacement over time, so Motion is a confusing thing if the motion of time is described simply as more motion. And we cannot ignore the element of time by not looking at something as separate and different from the motion related to time. Motion is the measurement of the actions of time. Examining the Greek word none to compare to instances of time, Stein's investigation of non-motion or change of time finds that now is not divisible and must therefore be another part of time. By that reasoning, the past, the present, and the future must either all exist or none of them exist. Aristotle's bottom line should be understood to mean that the indivisible now is a description of time, while the change and the motion are measurements of time. Change of number or not, Julia Annas said that it was natural for Aristotle to have thought of time as a kind of number. She emphasized that by number she meant the sense of what is countable, not what we count with. This does, in fact, come closer to describing time as a thing rather than a measurement. She referred to Aristotle's frequent discussions of what he called the now. His now is an indivisible, durationless thing akin to a geometrical point. Aristotle blended some early concepts. He flowed seamlessly from the idea that time should be thought of as the counting or measuring of time into describing time as a series of nows. If four-dimensional time were represented as drawings of 3 dimensions, we could imagine 4 blocks. There would be one block depicting time existing only at the present moment, number 1, presentism. And there would be broad divisions of eternalism, number 2, the block universe, number 3, the growing block universe, and number 4, the spotlight theory of time. Albert Einstein should be thought of in connection with the block universe. In the spirit of a true philosopher, he often crossed over the strict lines of his discipline of physics to address political, religious, and metaphysical themes. When his lifelong friend, Michel Besso, died in 1955, Einstein wrote to Besso's widow saying, "Now he has departed from this strange world a little ahead of me. That signifies nothing. For those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion." This quote is often misconstrued to imply that time does not exist. That conviction comes from people who misunderstand the way the word illusion is being used. They think he is saying that time is the illusion, not that the separation of the different parts of time is an illusion. Clearly, he is not saying that time is nothing more than an illusion. That would be a stingy reading of this quote. When read in context, the passage indicates that Einstein is there saying not that time itself is the illusion, but the separation of the parts of time is an illusion. It is clear Einstein is attempting to console the widow of his friend in this letter. He is telling her that the time she shared with her husband still exists in a different portion of what he often recalled four-dimensional space-time. How callous would be the interpretation that he was telling his friend's widow she should, for some unfathomable reason, not be sad because Besso was gone and any reference to him does not exist, never did, and never will exist. Think of the smiling face of Albert Einstein. He seemed much too nice a man to have written such a hollow message to a grieving widow. When he spoke of four-dimensional space-time, he was clearly discussing the construction of time as a physical entity, and he avoided the pitfall of discussions about different measurements of time. The growing block universe, by comparison, is a variation of the block universe theory. It is more inclusive than the block universe because it does not ignore the intuitive concerns of those who support that part of the presentist's view of time with a future that is not yet fixed. The growing block universe might be looked upon as the block universe in progress. The past has occurred and exists in the past tense sense. The present also exists in its special status because we interact with it, but the future is yet to be determined. Those who approve of the arguments for free will and resist the idea of fatalism, which says that the future is fixed and unalterable, should be drawn to the idea of a growing block universe. In some odd sense, it dovetails well with what we know about an expanding universe. We look at them all, the growing block universe compared to the block universe, presentism, and spotlight theory. We see both the measurement of time and the description of time.
Everything about time is discussed within a single all-inclusive package. A growing block universe does not easily fall into confusing logic loops of fixed futures or changeable pasts. It is also somehow soothing to the human spirit to think that the future remains to be written, while the past is not lost and therefore almost meaningless to us. When the English philosopher Charles Dunbar Broad coined the term spotlight theory in 1923, he compared it to a policeman's spotlight sweeping the fronts of houses at night. The spotlight theory is not so very different from the growing block theory, and it blends in some aspects of presentism. Like the growing block theory and the block theory, it combines the idea of all tenses of time existing together, past, present, and future, but a special condition exists for the present. Some would say it feels right. Again, we must ask if it is immodest to think that the present has a special status simply because we notice it. It is certainly special to us because it is all we can fully experience. Time may not be any different in the present, but it is what we see. It is a satisfying sensation to envision the present brightly lit up for us, while we acknowledge a past which is not entirely lost to us, and still we are able to believe in a future we can have an effect on. Persuasive arguments exist for all schools of thought about time. In many of his writings, Aristotle was very probably combining the concept of measuring time, its change as number, with the entity of time, the indivisible now. There was no real reason for him to keep the two views entirely separated. To be fair, there is not a tremendous difference between describing, for instance, one's observations about driving an automobile and then also describing the specific construction details of that same automobile. In close observation, they are separate perspectives of the same contraption, a car. As a first and generalized conversation about a car, however, both topics could be reasonably discussed together without major distractions arising. But one must realize that while considering a thing like the topic of time, after 3 millennia of people talking about the minor differences, the minor points become major differences. It may be that for many people, the moving spotlight theory is the best description of time. To better understand time, one might also compare it to other things like ultraviolet light, for instance, because both ultraviolet light and time are vague to our physical senses. We cannot directly see, feel, hear, taste, or otherwise experience time or ultraviolet light. We know that time in some sense passes with an arrow of direction, the order of causality in the universe. The same is true with light, ultraviolet light as well as other frequencies. Ultraviolet light is singled out in this discussion because, like time, it does not have a visible signature upon the human eye. We sense that it is there, but both time and ultraviolet light are things we cannot directly experience with our senses. At best, we are only capable of sensing hints about them. Skeptics are quick to dismiss any concept which intimates any possibility that things other than those which we can see and touch at the moment could exist. Perhaps it may be viewed as some sort of conjured up nihilistic sense of bravery to describe a bleak and meaningless universe. Why so fast to judge it so? It should be noted that science has conducted tests that clearly show time as a physical entity. Speed or gravity will change the pace of time between objects in different gravity environments, for example. Speed creates dilations of time and its measurements. We simply cannot see the mechanisms of these things at work because our senses are adapted to our own preferred scale, the here and the now. There are even examples of tautologies that seem to tell us that there is a limit to the speed of causality, which is identical to the speed of light. Time, it can be reasoned, travels like photons of light, indivisible nows that are like single units of time traveling as do photons. This only allows for things to happen in sequence. It explains the arrow of time. After all, indivisible nows only allow for events to happen prior to another now or after one. An event could not happen inside of one of Aristotle's indivisible nows. A moment from the future becomes the present, then passes into the past. This is the structure of time. None of us would imagine that in the middle of a moment we would experience a little part of an event from the past or the future, that it would suddenly insert itself into that moment. Time and causality flow along an arrow of time, and the present moment is not divisible. This is posited as an explanation of why causality is limited to the speed of light. Some graphing techniques explore surprising causality examples of objects undergoing extremes of gravity or speed.
The dilation of time by speed and/or gravity was predicted by Albert Einstein's theories of relativity. There can be different rates of movement through time. Time also acts as the regulator of the order of the universe. There exist paradoxes when discussing the order of causality when we contemplate communication between different rates of movement through time. For some reason, when talking about relative time, writers often use the names of Alice and Bob as examples. Well, let's look at Alice and Bob here, where Bob travels very fast and subsequently moves through time differently than does Alice. His clock advances more slowly than her clock. In the geometry of this example, we graph the adjacent of Bob traveling at 87% the speed of light, compared to the hypotenuse of Alice, who is stationary relative to Bob. His progress involves a shorter duration of time than that of Alice. It is as if we are falling through time, as if we gather up all of our three-dimensional paraphernalia and step off into a four-dimensional elevator shaft, and all falls at the speed of light. Falling through time in sync with one another, we do not see the motion of time until Bob's burst of speed slows his descent down the elevator shaft relative to our own speed of descent. Direction here is irrelevant. We're both measuring and describing time in this example. We are here discussing the shape of time as something which can be moved in at different rates, and we're also discussing how the clocking of time differs when we address Bob's 8 years of awareness compared to the simultaneous 16 years of awareness for Alice. The technical definition of causality is the study of cause and effect. Let's look at a hypothetical anecdote and ask ourselves how causality works. We just discussed Albert Einstein's time dilation as proven by experimentation, which allows Bob to travel through time at a different speed than Alice. See how he has traveled for 8 years, during which time Alice has patiently waited at home for 16 years. And for fun, let's say that there would be no limit to the speed of causality. After 16 years, Alice finds a radio not constricted by the speed of causality and sends a quick message to Bob. Alice sends the message in the year 2038, 16 years after Bob launched, but Bob receives it in 2030, 8 years before Alice sent it. Bob is delighted to hear from Alice because he has missed her all these years, so he immediately returns a message to her. Paradoxically, Alice receives an answer 8 years before she contacted him. We encounter some dilemmas here. In this scenario, the physical description as explained by the presentists would mean that the clocking of Bob's returning subsequent calls to Alice would be received at 4 years, and then 2 years, and 1.5, a quarter, and we begin to see the arrow of time in reverse. Causality would have its effect in the past, not in the future. There would be a fixed future and a changeable past. A block universe, growing block universe, or spotlight universe would all have problems too. We find endless loops. Year 16 calls would endlessly prompt year 8 responses. At year 8, Alice receives a reply forewarning her that at year 16 she will make a call, which she was aware of at year 16 when she makes the call. Would that not mean that she would make the call knowing that she had already been told about it, and then that call would make her twice aware at year 8, then 3 times, and so on? Year 8 would see an endless number of warnings about the upcoming call at the year 16 mark. But if she decided not to make the call at year 16 because of so many forewarnings, the entire cycle would disappear completely and never have happened. The growing block theory would have continuously changing past. The future would not be growing. The growing block universe would therefore be the ever-changing past but never growing universe. And spotlight theory would become a looping kaleidoscopic dance of change. Measuring time becomes important when questioning causality. A light clock is a thought experiment which gives us a hint about the flexibility of time. It measures time as a photon of light bouncing between two mirrors, and we will pretend here that it has a rate of 1 second per bounce. Because of the speed of light is constant and Bob's photon of light has to travel farther, Bob's clock registers a slower second of time. None of our models for time can function in a universe without a limited speed of causality, and although it seems redundant to speak of the speed of time as the speed of causality, the only way any of our theories of time can apply to the world is if causality cannot be interrupted. After all, Einstein's famous E=mc² means that physical matter becomes energy at the speed of light. Intuitively, we know the loop in Alice's world cannot occur. A call from Alice at year 16 would get a busy signal, so to speak. After all, photon-like segments of time cannot be capable of squeezing inside of other photon-like segments. Regardless of how they are measured, Aristotle's nows are indivisible and simply cannot be interrupted. In conclusion, we understand that time is a dimension we cannot clearly see. Imagine, if you will, existing in only the two dimensions of height and width, then being asked to describe the third dimension of depth, that which is in front of you and behind you. If you said this third dimension is made of meters or miles, you would clearly be describing a measurement of depth, not a description of what is actually in front of you or behind you. Time is the same proposition. It is here suggested that we use two different words to clarify this difference in regard to the dimension of time. Because the clock is our most commonly used instrument to measure time, perhaps when we discuss measuring time in a technical sense, we could use the term clocking. In this manner, we would be able to easily distinguish when we discuss clocking the change of nows, measuring time, or when we are describing physical attributes of time in the way we speak of size, shape, etc. St. Augustine said, "What then is time? If no one asks me, I know. If I wish to explain to him who asks, I know not." We can hope to better understand this vague thing we call time by clarifying the terms we use to describe it. Thank you.